Okay. All right. Well, let's go ahead and get started. So, this week, the goal is to get through the first lesson of our new unit where we're going to start talking about polar coordinates and graphs. And then second week after we get back, we'll have an exam over all this material, but I'm getting a little ahead of myself. Remember, tomorrow you have a quiz over trig equations. So there's 6 questions, okay, 5 of which are going to be multiple choice. So remember, there are going to be College Board problems on there. So at the end of last week, we were talking about solving equations that contained no special right triangles. So I wanted to go ahead and start the class today practicing that. Okay. So this is why you had that blank sheet of paper when you walked in. Okay. I've got 2 equations here that I'd like you to go ahead and solve. The first one is cosine of x equals 3/5. And then number 2 is sine of theta equals a negative 4/7. Okay. Now, what you're going to do is use your information about inverses. And I've put that up there. It's kind of small. I apologize, but it's the only way I can fit it on the screen to kind of help you out. So you want to determine what kind of angle you're working with. Could it be acute, right, obtuse? And more importantly, is it positive or negative? And then go over, solve it as a normal equation. All students take calculus. Okay, so I'm going to give you 4 minutes. Let's see how we do on these. That is 3/5. Cosine of x equals 3/5. And then the other one, sine of theta equals a negative 4/7. Maybe that'll help a little bit. Turn off the light. Coming up on 1. Okay, that's 4 minutes. Let's go ahead and check to see how we did. So number one, cosine of x equals 3/5. Here are the two solutions that I got. Cosine inverse of 3/5 and 2 pi minus cosine inverse of 3/5. And remember, if you decided not to use the -1 notation and you put arc in front of it, perfectly fine. Okay. Did we want to talk about number one? Anybody at all? Okay, cool. And number two, sine of theta equals a -4/7. Here's what I got. Pi minus sine inverse of a -4/7, and then 2 pi plus sine inverse of a -4/7. Okay. Quick question. If we had taken this for a grade, how many people would have gotten 100? Oh, that's good. A lot of hands going up. Okay. Did we want to talk about number two? All right, so for this one, the first thing I'm going to do is go ahead and solve for theta, which would be theta is equal to a sine inverse of a -4/7. So let's learn what we can about this as an inverse. Okay, quadrant 1 or quadrant 4? Okay, quadrant 4, because we have a negative ratio. So I'm going to draw my triangle right here. Remember, sine is y over r. So the height is -4, hypotenuse is 7. And you would have found that the other leg is the square root of 33. Yes, 33. So this is definitely not a special right triangle, but this angle still exists. I'm going to have to rotate clockwise to get to that hypotenuse. So this angle is represented by this right here. So it's sine inverse of a -4/7. All right. Now, being in one quadrant, okay, we know that it's acute. But more importantly, what type of angle is this? Is it positive or negative? It is negative. We had to rotate clockwise. Now, this is all we're going to get from the inverse side of things. We know it's a negative acute angle. We don't know anything beyond that. But now we're going to take it and we're going to solve this. Okay, so now as an equation, all students take calculus. Where is sine negative? Okay, 3 and 4. Okay, so I'm going to draw some triangles here in 3 and 4. In fact, it's the same two triangles. So we have a hypotenuse of 7, height -4. That's a negative, square root of 33. And this is the square root of 33. And these two reference angles, they are that sine inverse that we just had. Sine inverse of a negative, what was it, 4/7? Yeah. And then sine inverse of a -4/7. Okay. Now, what we've got to do is rotate from standard position counterclockwise until I hit each of the hypotenuse that I draw. Okay, talk today. All right. So a quick question. We went through 2 full quadrants. Why wouldn't it be pi plus that angle? Remember, because it's a negative angle. If I had adding right here, if I'd added the negative, that actually would have subtracted it. But when we subtract a negative number, that's when it becomes a sum, addition. So that would have pushed me into the third quadrant where I needed to be. Okay. And then for the other one here, all the way around to the second hypotenuse. Okay. Normally I would go ahead and take the full revolution 2 pi, and I would subtract that angle to get the majority angle that I want. So that's why I'm going to add that negative, because again, that's going to subtract it. Okay. Questions? Yes. No. Because it's a negative. Oh, you're talking about the 4/7? Remember, that's not an angle, that's a ratio. So when you're dealing with this, sine of theta is equal to a -4/7. Remember, that is your angle, while this is your ratio. So even when I go ahead and switch the two quantities and invert it, sine inverse of a -4/7 is equal to theta. Remember, we can only evaluate an inverse trig function using a ratio. Okay. All right. Any other questions? So one of the questions on the quiz tomorrow is going to deal with this concept. And in fact, you know how College Board tends to kind of want to do its own thing? Okay. Well, let me go ahead and give you a heads up. When we were solving equations, if you had an interval given from negative infinity to positive infinity, what was it asking you to do? You were going to find all the solutions. That means you would take your answers and add 2 pi n or pi n, depending on whatever trig function you had. Okay, so I'll go ahead and give you a heads up tomorrow. This particular problem, it's not going to directly state the interval, but it will verbally state find all of the solutions for this equation. Okay, so you do want to be careful about that. It's still going to be asking you just directly to go ahead and add whatever you have to your angle. Is everybody okay with that? Okay. Yeah. Yeah. Everybody. Okay. All right. Questions. Okay. Well, let me go ahead and get set back up for the next class. Yeah. Mm-hmm. Yeah, because the binomial itself represents your angle, so you want to have the angle plus or minus those intervals. Yeah. Mm-hmm. Mm-hmm. Exactly. Oh, like what he was talking about? So he was saying, like, if you wanted to go ahead and find multiple solutions, not just on the interval from 0 to 2 pi, like for this one here, because pi minus sine inverse of negative 4/7, that's one of your angle answers. So you could say pi minus sine inverse of a negative 4/7. And since we're solving for pi, you go ahead and say plus 2 pi n, where n belongs to your set of integers. So it's still the same. You're taking the angle and you're just adding the appropriate interval, I'll say, 2 pi or pi. Okay. Cool, 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 cool. All right. Well, we got that quiz coming up tomorrow. I think those are supposed to be reversed. There we go. Okay. I'm thinking everybody's going to do fantastic. Absolutely. I love the confidence. Okay. But remember, one other thing before we go ahead and get started, and again, I do apologize. Remember, all this week in the morning, there's no tutorials because I'm in the dining hall. But if you do have a question, how many people saw me walking around the dining hall this morning? Okay. If you see me and you have a question, stop me and ask. I'll still help you out the best I can, okay, even though we're not in the classroom. I will still have tutorials tomorrow and Wednesday after school. Okay, so let's put this to the side. Let's get into polar coordinates. Okay, now up until now, you've always dealt with graphs in the rectangular coordinate system, or as you sometimes may have heard it referred to as the Cartesian coordinate system. So it's an intersection of the x and the y axes, where their intersection being the origin. Your point is always x comma y. You move horizontally x and then vertically y. Well, now we're going to go ahead and move towards a polar coordinate system. So that's a circular system. Okay. Now, to define a point, we only need to state the angle of the point in standard position and the sine distance of the point from the origin. This just kind of talks about some pros and cons and some real-world uses for such grids. So I'm not going to sit there and read it to you. I would encourage you, when you have a few moments, go ahead and take a look at that. Okay. But let's start with our vocabulary. So this is that other sheet that you picked up. Now, to form the polar coordinate system, fix a point O called the pole or the origin. So you're still going to have an intersection of two axes, the x and the y. But instead of calling their intersection the origin, we're now referring to it as the pole. Okay, so the origin is now the pole. From O, construct an initial ray called the polar axis. So you might remember from your rectangular coordinate system, the positive x-axis, we always refer to that as standard position. So instead of calling it standard position now, the positive x-axis, we're going to call it the polar axis. Okay, so the origin is now the pole, and standard position is now the polar axis. And this right here is how you're going to be writing all of your points. right talk today. It's going to be r comma theta. So the radius comma theta. R is the directed distance from O, the pole, to P, and theta is the counterclockwise directed angle formed by the polar axis and the segment OP. So you know how with a rectangular point, you start in X and you move horizontally, and then the second value Y is vertical, but with the polar coordinate, you want to start with the second value. Locate your angle first, and then from the pole, you move towards that angle, whatever the length of your radius is. Okay, and then down here at the bottom it says when r is negative, we graph the point r comma theta plus pi. But I'll go ahead and explain what that means when we get there. Okay, yes. Yeah, so you could do it in degrees, but we are going to be focusing on this with radians. All right. Everybody have a chance to copy that down? Okay, give you a few more seconds. Okay. Right, here we go. Okay, so this is the same information that I was just talking about. The origin is now the pole. The standard position is now the polar axis. Okay, go ahead and let you take a look at that. And as I stated previously, we're going to be writing all of our polar coordinates as the radius, comma, the angle theta. Okay, so the first thing I have to do is make sure you feel comfortable plotting a point in a polar coordinate grid. So let's start with A, the point 2, comma, pi over 3. So remember, you don't start with the radius, you're going to start with the angle. So you still have 0 radians. We're going to start on the polar axis. Okay, and I'm going to locate pi over 3. So pi over 3 is right here. Now from the pole, remember that's the origin, I'm going to go towards the angle, the length of my radius. So in this case, I'm going to go 2 units out. So point A would be right there. Now, here's where you want to be careful. Always pay attention to how your grid is labeled. Like in this particular case, it takes 3 circles to have 1 unit. Okay, so every 3 circles is going to be 1 unit, but they might give you one that's not even labeled at all. As long as you're able to fit your radius on there, you can label them however you'd like. Okay. Well, let's try B. 1 comma 3 pi over 2. Now 3 pi over 2, we recognize that as a what? Starts with a cube. That's a quadrantal. So if I start in 0, 3/2 pi is all the way down here. So there's 3 pi over 2, and then I want to go 1 unit towards that angle. So there's B right there. That's all it is. That's how you plot a point in a polar grid. Okay. Pretty cool. Because it's polar. See, you got it. Or did you get it, or were you just... Okay, cool. Guys, I want to make sure. All right, there we go. All right. Okay, let's chill. Okay. Yeah, exactly. Okay, let's try C. 4 pi over 3. So what quadrant would this be in? Be in quadrant 3. So I got to rotate until I see 4 pi over 3, which would be right here. Okay. And then we want a radius length of 3, so that's going to be on the outer edge. So that's going to be C right here. Now, so far, only one class has taken me up on this. It's been a while since we've actually seen these radian measures from, the unit circle, even though this is in the unit circle. But we still need to remember the radian measures. Did anybody want to go ahead and fill those in? Would that help anybody out? No? So we're good? Because you'll notice they've got the angles located in quadrant 1, but none of the other ones. So everybody would be okay recognizing the other angles? Nobody wants me to write it, just want to check. Okie dokie. Then let's try D. So 2, negative pi over 6. Now, how is this one different? Now, we're going to start with a negative angle. So that means I'm going to rotate clockwise. Now, 11 pi over 6 is right here. So negative pi over 6, it's coterminal with that measure. So I'm going to go clockwise, negative pi over 6. We have a radius of 2. So right there, that's D. That's all there is to it. Questions? Easy, right? Super easy way to start the week. Okay. Well, let's go ahead and practice this a little more. So we got 6 points here, starting with point A. Okay. Now this one is labeled, I need 2 comma 7 pi over 6. So for these first 3, let's see if we can get some volunteers up here to plot these points. This is the time you want to come up. There's no math. You just have to find a location. Who wants to help me with point A? I see people pointing at other people. Okay. Carolina. So we got to locate 7 pi over 6. Now you'll notice, is this grid labeled? This one's not labeled. So let's go ahead and say the inner circle, that's 1 unit. And then we'll say the next circle is 2, and then so on and so forth. There you go. That's exactly right. So here's 7 pi over 6 and a radius of 2 from that. So that's point A. So I'll say this is 1, this is 2. Perfect. Thank you, thank you. Okay, just that easy. Who wants to help me with point B? 0.5, 3/4 pi. Nobody? Don't make me use the wheel of destiny yet. This is just a point.
May I try again?
Oh, no, I got a volunteer. There we go. So I need 1/2 3 pi over 4. There you go. So you're just going to estimate. Yeah. If the first ring is 1, well, then you're just going to go halfway out to it, and that would be point B. There we go. Now I need C, 3, a negative pi over 3. So you're going to first rotate clockwise, and then go a radius of 3. Who's going to help me with this? And remember, what do we got going on tomorrow? Oh, Mason was the first one to answer. There we go. Sure. I can't do that one too often. I'm going to use the Wheel of Destiny in a moment. I just didn't want to use it too early. You know what? I will accept that. Yes. So where is negative pi over 3? There you go. So it'd be coterminal with 5 pi over 3. There you go. That's all right. That's exactly right. So here is a negative pi over 3, and that is point C right there. There you go. So this far, nobody's having any issues, right? Pretty easy? Yeah. Oh, because, well, remember, it's going to be symmetrical. So kind of think about these lines going through the grid as spokes on a wheel. So you'll notice starting from 0, okay, here's pi over 3, so we had to go 1, 2, 3, 4. So that angle right there is pi over 3 radians, so we just did the same thing in the opposite direction. Okay. Now, starting with number 4, what's different? The radius is negative. Okay, this is the last thing I need to go ahead and let you know about polar coordinates. So let's say I wanted to go ahead and plot the point 1 pi over 4. Well, that's easy. Okay, I'm going to start at 0. I'm going to rotate to pi over 4, and then I'm just going to go 1 unit towards that angle. Okay, but here's the thing. If it's a negative radius, I'm not going to go towards the angle. I'm going to go in the exact opposite direction. Okay, and you can use these lines to help you out. So instead of going towards pi over 4, we're going to go in the opposite direction. So that point D should be right there. That's actually in quadrant 3. If the radius is negative, you go in the opposite direction to your angle. Okay. So now let's try E. Okay. So negative 2.5, 4 pi over 3. What quadrant do you think that'd be in? That would be in quadrant 2, even though I have the angle 4/3 pi. So I'm going to come around over here. Here's 4/3 pi. But negative 2.5, I won't go towards it. I'm going to go in the opposite direction. So that's going to be 12.5. So that's going to be E right here. Okay. And if you haven't already done so, go ahead and plot point F for me real quick. So negative pi over 6, and then a negative 3. Okay, so with a negative angle, we're going to rotate clockwise. Negative pi over 6, we just saw that is coterminal with 11 pi over 6. With a negative 3, we're going in the opposite direction. So this would be 1, 2, 3 right here. Okay, how are we doing? Anybody having a hard time plotting a polar coordinates? Okay. Then, let's try this one. I'm going to give you 1 minute, plot all 4 of these points. Now, this example is meant to go ahead and show you something I think some people might already be noticing. Go ahead and plot these 4 points, A, B, C, and D. Oh, I need to change that. Okay, so let's start with A. So pi over 4 is right here. I'm going to go radius of 2. So that's labeled this time. So that would be point A right here. But what did people notice when they started plotting the other points, James? They are all the exact same point. So if I started here at 0, okay, for point B, negative 7 pi over 4, that would rotate me all the way over here. Negative 7 pi over 4 is coterminal with pi over 4, and then I'm going to go a radius of 2. Okay, so that's B. Same thing for C, 9 pi over 4. Let's do this in a different color. Now, what's 9 pi over 4 as a mixed number? 2 and 1/4 pi. So if I were to start here, see there's 2 pi, and then I rotate an additional 1/4. So it's going to be the same thing. So there's point C. And then point D, let me do this in red. So we have to go 5 pi over 4, which would be right here. But then what happens with a negative radius? You go in what direction? You go in the opposite direction of your angle, which would have put you right there. Okay. So when you're dealing with a rectangular coordinate system, your XY point, there was only one way to mark a location. But what we're now seeing when it comes to polar grids, there's an infinite number of ways to mark the same location. Because I can go ahead with a positive radius, I can continue to rotate full rotations in either direction, or if I go pi radians in the other direction with a negative radius, I can continue to do that. All right. So with this in mind, let's go ahead and practice finding other coordinates that mark the same location. So here we go. Example 3, it says plot the point with polar coordinates 3 and then 5 pi over 6. Okay, so where's 5 pi over 6? What quadrant is that? Quadrant 2. So 5 pi over 6 would be right here. They've already got this grid labeled. We want a radius of 3. So that would be this point right here on the outer edge. Okay, so there's 3 comma 5 pi over 6. Now, this says we want to go ahead and write polar coordinates for 2 different ways. We're going to go ahead and do this and have a total of 4 points. We're always going to do this the same way. We're going to have 2 points with the same radius and 2 points with the opposite radius. Okay, so since we have a 3 comma 5 pi over 6, I want another point where the radius remains 3. And I want 2 other points where the radius is going to be negative 3. Okay, so this is how we do it. Rotate a full circle, okay, 2 pi radians in the opposite direction, and then r, your radius, is going to stay the same. Rotate a half a circle in either direction, pi radians, and the radius is going to change to the opposite. So let's say I want to keep the radius the same sign as I do. Okay, you're either going to choose to add or subtract 2 pi. Remember, it says to go in the opposite direction. So because we have a positive angle, what do you think I'm going to do? I'm going to subtract 2 pi. So I'm going to take 5 pi over 6, and I'm going to subtract 2 pi over 1. So if you were to be given a negative angle, you would add 2 pi to that. Okay. Now, realistically, whether you add or subtract, you're still going to find another coordinate for the same location, but I'm just wanting to keep everybody on the same page. Okay. Because really, if there's an infinite number of points, and I start to grade, quizzes and assessments, that could conceivably take a long time because everybody could have different points. Sure, do you have your back? Okay. All right. We'll take care of that in just a second. Now, if I want to change the sign of my radius, well, I'm going to take my angle, 5 pi over 6, and I'm going to both add and subtract pi to it. Because I want to get on the exact opposite side of the grid. Okay. Now, I'm looking at this. All we got to do is a little bit of algebra. What's the common denominator? 6. So I'm going to multiply this first one here by 6 over 6. So that's going to give me a 5 pi over 6 minus a 12 pi over 6. Well, if I subtract those, that's a negative 7 pi over 6. And you can confirm that looking up at the grid. Negative 7 pi over 6 with the positive radius is the exact same location. Okay. Now I'm going to do the same thing for changing the radius. Got the same denominator. So now it's a 5 pi over 6 plus or minus 6 pi over 6. I've seen people in the past do these separately, 1 plus, 1 minus. I think it's easier and faster just to do both at the same time. Okay? Because think about it. What's a 5 pi plus a 6 pi? So that would be an 11 pi over 6. But a 5 pi minus 6 pi, that's a what? Ooh, what kind of pi? Negative pi over 6. So all 4 of these points are the exact same point, the exact same position. Okay. All right. Questions on that? Let's go ahead and practice this a little bit. Let's get some more points. Okay, so our next example has 2 and then 5/3 pi. So just like we did before, I want another point where the radius is 2, but I want to find 2 other points where the radius is now negative. So if I want the radius to stay the same, this is when I'm going to take my angle, and I'm going to either add 2 pi or I'm going to subtract 2 pi. Okay. Which one am I going to do here? Because we have a positive angle, the opposite would be to subtract. Yeah. Okay. And then if I want to change the sign, that's when I'm going to take my angle and I'm going to add or subtract half a revolution, pi. Okay. Right. The only trick to this is just remembering, what to do. What's my common denominator here? Okay, so I'm going to multiply by 3 over 3. So let's see, that's going to give me a 5 pi over 3 minus a 6 pi over 3. So it looks like in order to keep my radius the same, this is going to be a negative. There you go. That's exactly right. Now for the other one, I've got 5 pi over 3 plus and minus 3 pi over 3. So what's a 5 pi plus 3 pi?
8 pi.
There you go. And you'll notice, what is 8 pi over 3 as a mixed number? 2 and 2/3 pi, right? Now you'll notice I went ahead and marked out where it says do it on the interval from negative 2 pi to 2 pi, because occasionally using this method, you're going to go outside that, so don't worry about that. Okay. And then I need a 5 pi minus 3 pi.
2 pi over 3.
There you go. And we've got 4 points that represent the same location. Anybody have any questions? Is anybody confused? Polar coordinates are not too bad, right? Okay, all right. I'd say everybody's getting the point. Okay. All right, so try this one for me. Okay, -5, -7/4 pi. So I want one additional point where the radius will stay -5, but then I want two other points where the radius is now positive. Okay, so think about what we've done on the previous examples. Yeah. Yes. Yes, Steve.
Since it's a negative, we have to add, right?
Yes, that's what I was waiting on. So because this is our first negative angle, taking the opposite direction, this is where I would add the 2 pi. But if you're wanting to change the sign, you always add or subtract just pi, half a revolution. You try to get on the opposite side of the grid. Okay, so what would the angle be for -5?
-pi/4.
Okay, I heard pi/4 and -pi/4. It would be positive because -7 pi plus 8 pi. And then we have a -7 pi/4 plus or minus 4 pi/4. So a -7 pi plus 4 pi, and then -7 pi minus 4 pi. There you go. Okay. How are we doing? All right. Very good, very good. Well, this is going to be my last problem. Okay. So a -1.5 pi/6. Okay, so I want one point where the radius stays negative, and then I want 2 points where the radius changes sign. That is a horrible point. I'm going to redo that. There we go. So 1 point. There we go. Okay, so this is where I want to use the Wheel of Destiny. So whoever comes up, all you're going to do first is find me the point where the radius stays negative. Okay, so let's see here. In here, we got to go to 29. Okay, so I need to add. Okay, let's give this a good shuffle. Here we go. Who's our lucky person? Oh, Carolina, you did already come up previously. You want to do it again? Okay. So you're going to take that angle pi/6. Are you going to add or subtract 2 pi?
Subtract because it's positive.
That's exactly right. Okay, so you got yourself a common denominator. So pi/6 minus 12 pi/6. What are we looking at? -11 pi/6. There you go. Fantastic. And let's do it this way. Instead of spinning the wheel again, Carolina, who would you like to see come up and get the other two? Well, James, you did come up today. Would you want to come up again? Okay, well, she picked you. Okay, I'm okay with that. Weston. See, look at that big smile on Weston's face. Okay. Okay, so Weston, we're now going to take pi over 6, and we're going to do what with it? If I'm wanting to change the sign of the radius. Okay, we're going to do something with it. Can anybody help me out? Okay, Oliver, what you got? So we're going to do what? We're going to add and subtract pi over 1. So let's go ahead and write down pi over 6. Okay. And now we're going to add and subtract. And did you hear what Oliver said?
Pi over 1.
Pi over 1. So what's our common denominator?
6.
Okay.
So you multiply 6 with pi over 1.
Do I add or subtract?
So you're going to add and subtract. When you're changing the radius, you're going to both add and subtract pi. So this is going to be pi plus 6 pi over 6. There you go. So let me go ahead and erase this right here for you. So what's a pi plus 6 pi?
7 pi.
Okay, so that'll be one of your points. Okay, and now what's a pi minus 6 pi?
Negative 5 pi over 6.
There we go. Okay, just forgetting one thing. You put negative 5/6.
Oh, 5.
All right, there we go. There we go. Fantastic. Hey, and now there's no need to burn the witch. So there you go. All right, well, that's all I got for today. Questions? All right, so we got less than 4 minutes. Let me go ahead and get this ready to go. Yes.
I'm having a little trouble determining whether to add pi or subtract pi, like on these two. Like in the following.
Oh, you're talking about.